Video 4 of Chapter J. This is section 7.4 in our textbooks. It is specifically similarity in right triangles, and I will be referring to a series of 3 right triangles today as Papa Triangle, Mama Triangle, and Baby Triangle. But we're first going to need to discover where these 3 individual right triangles are going to come from because they're all going to be crowded together. So first off, a vocabulary word we need to discuss is altitude. Now, altitude is something that we've been working with all year. Altitude is essentially what I have highlighted down here. It's the height to a base. For example, if we wanted to find the area of a triangle, we would need to know which side of the triangle is the base, and then we would need to know the height to that base. And the other term that we could use to describe the height to the base is the altitude to the base. Now, there are various situations in which we could have the altitude. For instance, in an acute triangle, if we said this was the base down here, then the altitude would come from the vertex opposite of this base and drop perpendicularly down and make a right angle down here to the base. In an obtuse triangle, the altitude could be on the outside of the triangle, but it's still perpendicular eventually to the base if you extended it out a little further. And in a right triangle, well, the altitude, again, if the base is the bottom here, then the altitude could be one of the actual sides of the triangle. Now, it's in this video that we are going to be talking about the altitudes of right triangles specifically. Now, again, the altitude could be drawn to any of the 3 sides. So let me just throw this out here because there's 3 specific scenarios, but we're only really going to focus on one this video. So if this was the base, then the altitude would be this side so that it's perpendicular to the base. Now, on the other hand, this could be the base of the triangle, and its altitude would be coming from the opposite vertex and being perpendicular to it. So imagine this triangle is basically on its side. It's being rotated 90 degrees so that the left side here, not left side, the right side is the base, and this bottom side is the height. Now, the third scenario is the one that we are really going to be discussing, and that's if the hypotenuse of the right triangle is the base, then the altitude would have to start at the right angle's vertex here and drop over to it so that it is perpendicular to it. So it's going to be this scenario again right here, where we have a right triangle, and we're going to be discussing specifically the altitude that is coming from the right angle across to the hypotenuse so that it is perpendicular to the hypotenuse. All right. So now I've got what's true about these triangles, but there's only one triangle here. Here's where we're going to get our introduction to the Papa triangle, Mama triangle, and Baby triangle. The overall big right triangle is going to be the Papa triangle. But where are the Mama and the Baby triangle? Well, the Mama and the Baby triangles are going to be the 2 triangles that are a result of drawing in the altitude. So imagine up here, at the right angle, I'm going to draw in the altitude so that it's perpendicular to the hypotenuse. And so now I get these 2 new right triangles. So I'm going to be able to spread these out a little bit more here. So imagine I have this triangle, and really imagine this is kind of its ghost image, that here's the altitude that's being drawn in. And we get these 2 new 90-degree angles. Now, I can really split all these apart here, and now I could kind of overlap these so that you could see how they fit with the original Papa triangle. So the smallest right triangle that we're going to see inside the big right triangle, we're going to refer to this as the baby triangle, the baby right triangle. And the medium one, the other one that's connected with the baby, here's Mama, and then the Papa, contains the baby and the Mama all together. All right? Now, we're typically not going to see these 3 right triangles all separate like I have here. They're all going to be really kind of crammed inside just one single triangle. But what I want to point out to you is this. And we've been talking about similarity this chapter, and we have three shortcuts to prove triangles are similar. We have angle-angle similarity, we have side-angle-side similarity, and we have side-side-side similarity. And we're going to need to discuss how these three triangles are all similar to each other. And notice we're not talking about specific side lengths here. So we're not going to be focusing on the two shortcuts that involve sides. We're going to prove that these three triangles are all similar by angle-angle similarity. So we need two sets of congruent corresponding matching angles between each of these three triangles. Now, the easy thing to comment on would be, well, they all have 90-degree angles. True. So there is our first A of angle-angle. They all have matching 90s. Now, they will all have another set of matching angles and also a third set of matching angles as well, but they're not as obvious as just the 90s. All right? So let's talk about the others. So imagine if I took the baby triangle and I put it back inside the papa triangle. So again, notice papa triangle has that big 90-degree angle. Baby triangle has this 90-degree angle. There's a set of matching angles. And there's got to be some other angles that match up between the baby triangle and the papa triangle. And if you notice here, look at angles 1 and 4. 1 is in the papa triangle and 4 is in the baby triangle. But notice they overlap each other perfectly. So those two angles, and now let me re-separate them back out, angles 4 and 1 are really the same exact angle as each other. So now we've established that both the papa triangle and the baby triangle are similar by angle-angle similarity, which means that the third angles, which would be angle 5 in the baby and angle 3 in the papa, they must also be the same, right? By one thing could be theorem 4.1, that if two sets of angles are the same between two triangles, then the third set of angles have to be the same. So I could go put 2 arc marks on angle 5 and 2 arc marks on angle 3. So now I fully established that all three sets of angles have to be the same between the baby triangle and the papa, if I can write papa, the papa triangle. But now let's bring mama into the mix. So if I put mama back where she really belonged inside the papa triangle, again, notice they both have matching 90-degree angles, check. And just like with baby triangle, mama triangle angle 9 and papa triangle angle 3, they're reflexive angles. They overlap perfectly with each other. So if papa triangle already has 3 arc marks on angle 3, well then we should also get to put 2 arc marks. If I said 3, I meant to say 2 arc marks for angle 3. We have 2 arc marks on angle 3. We should also get to put 2 arc marks on angle 9 of the mama triangle because, again, they're really identical angles to each other. Now, that means if angle 2 and 8 are matching 90-degree angles and 3 and 9 are matching 2 arc arc angles, then these two triangles, the mama and the papa, are really similar by angle-angle similarity, which means the one angle we have left here, angle 7, how many arc marks does it deserve? Well, it must have 1 arc mark on it. So angle 7 must be the same as angle 1 in the papa triangle and the same as angle 4 in the baby triangle. So all three of these triangles, the baby, the mama, and the papa, will always be similar by angle-angle similarity. Now, the fast and quick way that I label all the angles with 1 arc marks and 2 arc marks is this. So let me go back all the way to the original here. Is if I have the altitude drawn in from the right angle of the big papa triangle to the hypotenuse of the papa triangle, and go ahead and draw in those 90-degree angles here, all three triangles, baby, mama, and papa, all have matching 90s. So now the fast way that I mark all the other angles is in the big papa triangle, I'll put 1 arc mark on one of the angles, and I'll go put 2 arc marks on the other angle, again, of the big papa triangle. And then inside the smaller baby and mama triangles, if I've put 1 arc mark here in the baby triangle, then this sliver of papa's 90, this must get 2 arc marks. And in the Mama triangle, if I've already used 2 arc marks, then this other sliver up here must have 1 arc mark. So if this has 1, this has 2, then basically the 2 and the 1 get flip-flopped up here. Is kind of the fast and easy way I remember this. So example 1, brought to you in part by winter puppies. Winter puppies, always snuggly, and always with snow on their muzzle. Why is a puppy there? I don't know. I think I made this sometime around Christmas time one year, and for some reason I put a puppy there. I don't know. Anyway, example 1, we're going to solve for x here. So notice, big Papa triangle is a big right triangle. There's the main 90-degree angle. And the altitude is coming from the vertex where the 90-degree angle is. It's going up to the hypotenuse, and it's making a 90-degree angle up there. So we get to put another 90-degree angle adjacent to it, straight angle postulate there. And then, so this is going to be my baby. This will be my mama. And then Papa is usually just understood that it's the big one, okay? Now I'm going to go mark all my angles on here as well. So I'm going to put the 1 arc mark of Papa up here. I'm going to put the 2 arc mark of Papa down there. So I got 1 arc mark, 2 arc mark, big 90 for Papa. And then if I put 1 arc mark here in the baby, then the 3rd angle in the baby, the one that's down here by Papa's 90, is going to get 2 arc marks. And then adjacent to that is going to get 1 arc mark. Now, how do we actually solve? Because all we've talked about so far is how these triangles are all similar to each other. And if they're all similar to each other, then their sides are proportional. So we get to set up a proportion problem so that we can cross multiply and solve for a missing piece. So now the big problem is this. To set up a proportion, we need to work with 2 triangles. But we have 3 triangles in these problems, right? Baby, mama, and papa. So the main thing that I focus on is I look for 2 triangles that really have 2 pieces of information in them, whether they be actual numbers like the 4 and the 12 here, or maybe just something that's not known yet, like the x in this problem. Now, for instance, sides like this side and this side, there is nothing labeled on them, and I don't know the actual length of them. So I'm just going to assume that I don't really need to know what these are at this point. I mean, maybe it's some other future problem. I might need to know those, but I'm just going to stick with what's labeled for the most part. So in the baby, the mama, and the papa, which 2 triangles do you know the most information about? And we really need to know 2 sides. Now, notice in the baby triangle, there's 2 things that are labeled. We got this side is 4, and this side is x. And then notice in the mama triangle, we know 2 things. We know the x is labeled, and we know this 12. You might go, but what about poor Papa? Well, look at the big Papa triangle. In the big Papa triangle, we don't know this side, we don't know that side, and they're not even labeled. The only side we really truly know is the hypotenuse, which in the end is 16. So we're not more than likely going to work with the Papa triangle. We're going to work with baby. So I'm going to set up a baby ratio. We're going to set up a mama ratio of sides. So a baby ratio of sides is going to be proportional to or equal to the mama ratio of sides. So then I jump to the baby triangle because I started with it first, right? And so I know the 4 and the x. So I could write this as 4 over x as a ratio or x over 4. It really doesn't matter for the first ratio. So I'm just going to stick with x and 4. Now, in the mama triangle, how do I know if I need to write x over 12 or 12 over x? So here's the part that you need to investigate. And we're going to go back to the baby triangle. So I'm going to make myself some notes here. The x in the baby triangle, here's the x side in the baby triangle. It is opposite, and I'm always going to use the opposite angles to kind of make this reference. But the x side in the baby triangle, it's opposite the angle that has the 1 arc mark on it. So I'm going to put a little 1 right next to this x. So the 1 arc mark angle is opposite to the x side. The 4 in the baby triangle is opposite the angle that had 2 arc marks on it. Now, here's where sometimes I'll have students make a mistake, and instead of putting a 2 here, they'll put 90, and they'll go, look, 90 is opposite that 4. But that 90 is in the big Papa triangle. You need to make sure that you focus on the correct angle inside those smaller triangles, the baby and the mama. So now in the mama triangle, I need to follow that same pattern. I need to go find which side is opposite the one arced angle in the mama triangle and which side is opposite the two arced angle in the mama triangle. So now, hunting in the mama triangle. Where's the one arced angle at in the mama triangle? Right here. Which side is opposite of it? That would be the 12 is on the opposite side. So I know the 12 has to go in the numerator. And then which side is opposite the two arced angle? Well, here's the two arced angle in mama. What's opposite of it? That would be the x. And so now here's my proportion that I can now cross multiply and solve. So cross multiplying x with x, I'll get x squared. Cross multiplying the 4 with the 12, I get 48. And so now I'm going to need to square root both sides. So square root cancel. And I need to simplify the square root of 48. Now, the easiest way to simplify it would be 16 and 3, and the square root of 16 is 4, and the square root of 3 is stuck. So x in this problem is 4 times the square root of 3. Now, if you tried using the Papa triangle, you would get stuck. You would end up with more variables than what you could really solve with. So there's ideally going to be one particular set, one particular proportion that's really going to allow you to solve for what's being asked for in the problem. Example 2, brought to you in part by 4 candy canes. Solve for x and y. So we're going to set up 2 problems here. So notice big Papa triangle. We got this great big right triangle, and here's the altitude that's being drawn from the big right angle down to the hypotenuse. So first thing I'm going to do is establish all of my angle markings. So another 90-degree angle adjacent to this 90-degree angle. And then big Papa triangle, I'm going to go put 1 arc mark over here, 2 arc marks over there, and then flip-flop the 1 and the 2's for the big 90-degree angle up here. So if this had 1 arc mark, I have to put 2 arc marks here to complete the 1, 2, 90. For the mama triangle, this will be mama triangle. This will be my baby triangle. And it's got a 90, a 2 arc mark, so this angle up here must have the 1 arc mark. Okay, so now, out of baby, mama, and papa, which 2 triangles are we going to deal with? Well, let's see. Which triangles do we have 2 pieces of information about? I would say first let's start with baby. Looking at baby, how many sides are marked with at least some sort of value? Well, this side we know is 6 root 13, and this side's 13. And the hypotenuse, we don't know what it is, but hey, we could use the Pythagorean theorem to figure out this side. So, I mean, we could put a question mark here, but we're just going to leave it alone. We're not actually going to figure this out. So baby triangle, it's got a lot of good information, right? There were no variables technically in the baby triangle. Again, keeping in mind, we could solve for this piece here with the Pythagorean theorem because it's a right triangle and we know 2 sides. If we go look at the mama triangle, how much information do we know about it? Well, we know this side's x, we know this side's marked as y, and we know this side is 6 root 13. Okay, so mama definitely feels like we're going to be working some point with the big mama triangle, right? The medium mama triangle, I should say, because it's got an x and it's got a y. How about papa triangle? What do we know about papa? So in big papa here, we've got the y side. We've got this side, which we don't have anything labeled. But again, remember, we could figure out what it is with the Pythagorean theorem and the baby triangle. And then the hypotenuse, really we got this x and this 13, but that just means that the whole hypotenuse is x plus 13. So it's basically the big papa triangle. It's like the mama triangle, right? It's got the 2 variable pieces in it. There's an x thing we don't know about it, and there's a y thing we don't know about it. So the papa and the mama are really, really similar to each other. They both have an x and a y. The mama was a little bit better because at least we knew the third side of the mama besides the x and the y. The baby triangle had a lot of good information in it, right? It had a 6 root 13 and it had a 13. So I'm feeling like maybe we should use that baby triangle. So I would say let's just start. Let's start with the baby triangle, and let's see how well the baby triangle works with the mama triangle in setting up a proportion. And remember, we're allowed to set up this proportion because all three of these triangles are similar by angle-angle similarity. So because of this, we're allowed to do this. All right, so baby triangle, again, we have these two sides, 6 root 13 and 13. I can set them up however I want to. So let's say I put the 6 root 13 in the numerator, the 13 in the denominator, but now we need to make some little notes here. Which angles are opposite of these two sides? So in the baby triangle, the 6 root 13, that's opposite the 2 arced angle. So I'm going to put a little 2 next to here. The 13 in the baby is opposite what I called the 1 arc mark. So if I go to the mama triangle, I need to talk about the 2 arc mark in the numerator and the 1 arc mark side opposite the 1 arc mark. So in mama, what's opposite the 2? So here's the 2 in the mama. Opposite of it is x. So x goes up here. And opposite the 1 in the mama triangle, here's the 1. Opposite of it is the 6 root 13. So am I going to be able to solve this proportion? We've got just the one variable x, so we can solve this. So when we cross multiply this way, we're going to have 13x. And when we cross multiply the other way, we're really going to have 6 root 13 times 6 root 13, which is really just 6 root 13 quantities squared. So this is just 13x. We can multiply the 6's together and get 36. And we can multiply the root 13's. Ooh, wrong one. Highlighter. There we go. Root 13 times root 13 is 13. Now, I could multiply 36 and 13, but that's going to be a little silly because in my next step, I'm going to divide by 13 to get x all by itself. And those 13s will cancel out nicely. So in the end, x is 36. So there's how we solve for x. X is 36. Now, to solve for y. Well, now we could go set up another proportion. We already dealt with the baby and the mama. And with the baby, we already worked with these two sides. And we're not going to be able to get to y using the baby ratio because the y in the mama triangle is opposite the 90, and opposite the 90 in the baby was the one side that we kind of said, kind of who cares about for right now. We could figure it out, but first we'd have to use Pythagorean theorem. I would venture to say, to figure out the y in the mama, why don't we now look at the hypotenuse of papa, because we now know the full thing of it. The whole big hypotenuse is 49. So let's go use the mama triangle with the papa triangle. And let's see what happens with that. So let me get some room here. I'll leave this answer up here for now. So if we went mama and we tried papa. So mama, we know, well, I mean, we know two of the sides here. And I'll give you a little spoiler here. You could just use the Pythagorean theorem in the mama triangle to figure out what y is. But the whole point of this video is to set up proportions. So I'm going to continue to do this. But just know you could use Pythagorean theorem. So in the mama, I definitely want to use the y. But now I've got options. Do I want to use the 6 root 13 or the 36 as the side to work with y? And I would rather use the 36 than the 6 root 13 just because it's a whole number. And so let's make some notes here. The y in the mama triangle is opposite the 90-degree angle, and the 36 in the mama triangle is opposite the 2 arced angle. Nope, too far. There we go. So now in the papa triangle, we need to go opposite 90, opposite the 2 arc marks. So opposite 90 in the papa, that's the big hypotenuse, which altogether is 49. No, keep that. And what's opposite the 2 arc mark in papa? Well, here's the 2 arc mark in papa. Opposite of it isn't the 6 root 13. That's opposite the 2 arc mark in the baby. We got to go all the way across. There's the big side of the papa, which is y. And so now notice in this, we only have one variable, so we can cross multiply and solve it. So now let me erase all my x information here. So y times y is going to give me y squared. And then 36 times 49, it's a big number. I'm just going to write 36 times 49 for right now. And you're going to go, that's kind of weird. Why would you do that? Because my next step, I have to square root both sides. And the main reason why I didn't want to multiply those is because 36 and 49 are perfect squares. So we're allowed to do this. The square root of whatever 36 times 49 is the same as the individual square roots of those numbers multiplied together. And that's 6, and this is 7. And 6 times 7 is 42 for y. And we said earlier x was 36. Now, just to show you that it really does work that same way, if I took 36 times 49, the really big number I would have gotten would have been 1764. And the square root of 1764 is 42. Mind's blown. So this is where it's going to get a little more intense. It's where you're going to have to solve for more than one piece at a time. And if you initially set up a proportion that you can't solve, then you just have to go hunt and try to find a different proportion that you can solve. So for example 3, the last example here, I want you guys to try to set this one up and solve it. Now, at least try to set it up. The solving aspect will definitely be a little more algebraically intense than examples 1 and 2 that I did here. But we will definitely discuss this problem the next day in class. So again, at least try to set this one up to the best of your ability. And if you want to try to solve it algebraically, knock yourself out. Good luck.